Guys, welcome back to my channel. So today quote is, the distance between dreams and reality is called action. So when you take actions, you can convert dreams into your reality. So basically in this video we will talk about race condition. Let me just write it. Race condition, that's it. Now we have talked about the threads, and till this point everything looks good, because now we know that threads are important. If we want to execute multiple things at the same time, threads will be very useful. Now sometimes we create two threads, sometimes we go for multiple threads, maybe 8 to 10, it depends upon your application. And as I mentioned before, there are certain times when you actually write threads by yourself, otherwise most of the time your framework will do it for you. So let's say you create your own thread, and then we know that threads are good. On the other hand, let me just try it. There is thread, and on the other hand there is a concept called mutation. So basically mutation simply means that you can change something. It means you can change something, right? Let me just fix it. Yeah. So for example, there are variables, or specifically primitive type variables or object type variables. We can change them. Example, if I have, let's say, I is 0, and when I do I plus plus, and then I values become 1. So I'm changing this value of I by saying I plus plus. So I'm assigning the value of for I to 1, and I can change this value, and it is actually useful to mutate a value. And of course that's what we do with data processing. So when I say you have got data, you want to process it, and most of the time you want to change the value of variable, and that makes sense, so that it is mutation. But then if you remember, when we talk about strings, we have mentioned that strings are immutable. So there are some concepts which makes them immutable. So which is good, mutation or immutable? At this point, if you can change something, mutation looks good. But then let's try to discuss something more. So our threads are good, of course if you want to make things faster, threads are good. But then what if you mix both of this, mutation, threads with mutation? Okay, so will this work? So what I'm saying is, what if you have two threads, let's say T1 and T2. Let's say there are two threads, T1, T2, and make it T2 here, T2. Okay, fine. And suppose T1 changes the value of I, and there is some another variable I. So T1 changes the value of I, and similarly T2 wants to change the value of I. I think it will create instability in your code. Think about this. Let's say you have a bank account, and you have, let's say you have one bank account, and you have, for this purpose, you have, let's say, two debit cards. And you have given one card to your friend, and one card to yourself. Yes, it's me. Now consider a situation, you both went to the ATM machine. There is a machine, here is ATM. You both went to the ATM machine. Now you are trying to withdraw the money and your bank account is initially, let's say your bank has only 10,000 rupees. Correct. But both of you would go to the bank. Both of you reach the bank same time and trying to withdraw the amount of let's say 7,000 each at the same time. So basically you are totaling withdrawing 14,000 but the balance is only 10,000. So that's an issue if you try to do things simultaneously. And we can also do that in the code as well, so just to see what happens. So basically the concept of threads and mutation together is not good. Of course there is some method which can do mutation, make it thread safe. So thread safe basically simply means that only one thread can work with that at one point. And now let's go to the VS Code and start it. There is a two method show here. These are, and if T1 executing the show, T2 can't execute the show, so there is a restriction we can do. But how? So I can, before diving into that particular thing, I would like to introduce a new concept which is which is your lambda expression. In which you don't want to create a class then in using it below. You just simply write the whole logic of the class inside your expression like this. Just clear it. You don't need the method also, just pure logic. Yeah, that's fine. And similarly for the second object, let me paste it from here to here. Okay, and now increase the iteration to 1000. And now let's say, so basically we convert the classes based orientation to the lambda expression, right? And suppose we just create a class counter. I think I've already created it. Counter class basically which increment the count by 1. Initially the count is 0 because that's an instance variable. Cool. And we just got rid out of these two class because we don't need it further. Yeah, it's fine. It will make your code clean and crisp. Okay, and yeah, so create a variable of counter class. Let's say counter C, new counter, and call it here, and similarly here also. So basically we increment the counter class, and we would like to print and see the result, what will happen. System.out. Let's say c.count. So we have run two threads 1000 times and we see the output, and we consider that output is to be 2000 because each thread run 1000 iteration each, and the total count is 2000. Okay, let's see it. First compile it, and then we run it. Oops, just 197, 312, then 363. Oh, what is that? We wouldn't get our 2000 result, but we see some random number. Why? Because let's see it. Why? The reason is, let's say there is main here, main method. It calls, and it basically under the hood. It looks ugly. Just remove it. Yeah. It basically under the hood call two methods or run two threads. Yeah. T1 and let's say T2. So two methods, and then we print a variable count. So what main do is, during the iteration it will not wait to completion of T1 and T2. It will just count whatever the iteration of the T1 and whatever the iteration the T2 had completed, and it just count the result. That's why, as you see here, we get some results of 262 thread, 255 random results. So what we want is, please wait till both completed, and we can see that basically we want to first join the both. Join basically means to complete whole thread execution and then print the count, so we know what is the count after that. Okay, so let's do that. So before printing, first join both the threads, and it will throw some error, and we can just quick fix by throw declaration here. Okay, now let's again compile and run the code. And now we thought that after doing this joining stuff, we got 2000 iteration because we have done 1000 iteration both each. Okay, let's try it. Compile and then run. Oh, 19, so close, but not 2000. Yeah, again here we got 2000, but so why this is missing the threads execution? Because when we join two threads, let's say hold on, yeah, let's say count is count plus 1, and suppose initially thread was 0 and thread 1 execute, it will make count to 1. Now thread 2 enters and it will ask what is the count variable. It gives the value 1 and it increase, it gives 2. So in one iteration or in one cycle we increment 2 times. So during this discrepancies, we say that both threads work on the same variable or same function simultaneously, and it causes instability. As you've seen here also, we have not got our result proper. Look, 805, 500, of course we got 2000 also, but there is instability which we talked about earlier using mutation with threads. So what we can do to remove this immutability or instability, we just use a simple word here, synchronized, and now run it again. First compile and then run it. Let's, yeah, here again, yeah. So as you see here, now the code is stable. Each iteration you got 2000. What does that word synchronized do? Let me explain this. Synchronized basically tell thread that only one thread work at a time. So both simultaneously threads do not increase or decrease the counter variable value, or call the function counter to increase or decrease the value of variable. Synchronize basically do one work at a time, and then another thread introduce after completing one thread another thread work. So in this way we got our complete iteration of 2000, and we don't lose the values in between which we lost earlier. So that's the whole story behind using mutation and threads simultaneously. Thank you.